Hey, hi, my students. So you are receiving this because you have completed your questions on the play called The Tale of the Sun King and the Pressure Fairy. Really, for you, it was a puppet show. And like I said in the videos, I'd hoped to dress some of you up as the Sun King and the Pressure Fairy, but that just didn't work out. So I wanted to go over these answers with you. And so all of these lessons are building towards solving who committed the crime of stealing California's water in 2015 and 16, when that state was in a terrible drought, an exceptional drought, as scientists would call it. And so as we look through this, let's go and remember scene one together. So in scene one, you had the Sun King here. And the Sun King was saying that was approached actually by Air Mass Number One. And Air Mass Number One offered something to the Sun King. What the Air Mass offered was this element on the periodic table, hydrogen, a common element. And so checking your work now, in scene number one, you should have had that Air Mass One wanted to give hydrogen to the Sun King, and the King liked it. So as Air Mass Number One bowed down to the Sun King liked it because hydrogen is actually fuel to stars. There's a process called nuclear fusion, and just like gasoline to a car is the fuel, hydrogen to stars is the fuel. And so once that happened, the king did like a little spirit fingers to air mass number one and gave his heating to this air mass. So this is an air mass that does have energy from the sun. And all of a sudden, popping in was a new character in the puppet show. The character was the pressure fairy. And the pressure fairy came in to give air mass number one a sign. And that sign that you can see on there is low pressure. Okay, so now let's think this through. You have to think to yourself, is this air mass hotter or colder? Well, did this air mass actually get energy from the Sun King? And the answer to that is yes. So you have this warm air mass. So here's the deal with warm air, and you probably have heard this. If you have a house that's not air conditioned or you don't have the air conditioning on, it is always warmer on the second floor than the first floor if it's a two-story home. And so the reason for that, finish my thought, is that hot air actually rises. Now, what is the science of hot air rising? So when you picture hot air, do you picture in your mind the molecules scrunched or spready and moving fast? And the right answer to that is with hot air, you should actually picture the molecules spread out and moving very fast. And so that's the reason that the hot air rises. The air is less densely packed, lower density. Now, here's the deal. Because it is less densely packed, the air rises higher. But wait, hot air rising higher, should we give it low pressure? And the answer is yes, because pressure is all about the force that the air is placing on the ground. So here it is again. Hot air rises higher, but its pressure on the surface is actually lower. That's confusing historically for my students because we think hot air rises higher. Shouldn't it have high pressure? No, it's all about the force that air is applying on our surface. Okay, so now let's check our work. Question 4 is actually the most important so far. So number 3, you should have low pressure as the sign that the pressure fairy gave to air mass number 1. Now, this is the one where you're really going to have to pause and check your answer. Notice that I have some words underlined: density, rise, and force. And so you know how sometimes I'll say, if you're close, that's okay. This is really one of those times when I want you to be word for word. So number 4, the molecules spread out in hot air. I know I just said word for word. If you say that the molecules move faster or are further apart, something else instead of spread out that's close to that, but I want you to visualize that spreading out. Now, because the molecules spread out, they are not as densely packed. So that's low density, and that's the reason that low density rises. Now, I don't want to be gross, but this is middle school. Farts rise in a bathtub because the gas is less dense than the liquid water. It's the same thing. Hotter water is going to rise up because it has a lower density. Now, even though it rises higher, the pressure is actually lower because it's pushing on Earth's surface with less force. So less force on the Earth equals low pressure. Okay, of course, you can pause me right now as you need to and go to your doc and fix things up. Okay, so now let's go on though to scene 2. So scene 2 is similar. We still have the Sun King. We still have an air mass. And I didn't say this, but an air mass is basically a big clump of air that all has the same characteristics. And this air mass bowed to the Sun King and presented the Sun King with helium. Now, was the Sun King super science excited about some helium? And the answer is, the Sun King was not excited about that at all. So let's look together at questions 5 and 6. So helium was presented, and here's the reason the king did not like it. The Sun King didn't like it because helium is a waste product to a star. As stars use hydrogen for this process called nuclear fusion, they don't actually burn like a bonfire. They produce heat and light by fusing together hydrogen. Helium is given off as a waste product. You'll learn more about that in high school physics or astronomy. So, like a car doesn't want the exhaust fumes to run. A helium is not wanted for a star. Okay, so in comes the pressure fairy. And so you remember that air mass number 2 was just sent away by the Sun King with no heating. So the pressure fairy comes in and taps air mass number 2 and gives air mass number 2 high pressure. And so this is really easier now because question number 8 is super important, but it's the exact opposite of question 4. So we know that, that was a mistake. 1 minute. That should say 7 and 8. Okay, much better. So question 7, high pressure is the sign for air mass number 2. And now notice that I have just reversed everything. Instead of the molecules spreading apart like in warm air, in cold air, the molecules condense. They scrunch together. And this is the definition of high density, scrunchy mass. So this high density air will sink. Cold air sinks. And because it's sinking lower, this is where it gets confusing. Cold air sinks lower, but its pressure isn't low. Its force on the earth is actually higher. Okay? So you can pause me right now and go back in and fix anything. Like if you said the molecules get closer together instead of scrunched together, that's just fine. Okay, so now let's look at this together. This is nothing that you need to write, but I put this together, this sequence of slides, to really demonstrate what we mean by density. So density is the mass in the space. Now here we have the same amount of space, but notice in cold air, there's a lot more molecules scrunched together. In hot air, they're zooming around fast and they're not close together. And this is the reason that cold air will sink lower. So when it sinks lower versus hot air rising higher, you get a pressure difference. So the Sun King is not an even heater. And because he does not heat evenly, you get different temperatures of air with different air pressures. See this? Cold air is sinking lower, which actually makes its pressure on the surface higher, can push with more force. Hot air rises higher, but that means its pressure is actually lower. If you can stop and think, what does hot air do? What does cold air do? Then you can really reason through the rest. Okay, now scene 3 really wasn't a big deal. It was just air mass number 2 approaching air mass number 1 and challenging him to a fight. The reason he did that for question 9 is that air mass number 2 wanted low pressure. He was stressed out. So then scene 4, we had a battle. We had a battle in front of the Sun King and the Pressure Fairy in the Kingdom's Grand Stadium. And I want you to think about who actually won. So we have air mass 1 with low pressure and air mass 2 with high pressure. Now, if I was going to put another science word in for pressure, I would say force. So what makes sense? Would low force air or high force air be able to move the other one out? And so the Sun King was not correct. The Sun King thought air mass 1 would win because he blessed him with heating. That was not true. So question 10, air mass 2 moved air mass 1 out of the way. If you put air mass 2 won, that's true, but you need to say how air mass 2 won by pushing air mass 1 out of the way. And that is the point in this play where wind was actually happening. Now, how do we know that? Question 11 is super important here. So I want you to make sure that you have wind is moving air. Now, what actually causes this? Uneven heating. If the Sun King was fair, you would never have wind. And because of uneven heating, you get different air pressures. You know what? I'm going to underline. Hang on just a second. I'm going to underline this. High pressure air always moves out low pressure. High pressure air is always going to win because it's more forceful. Now let's put this lesson in context. We know that California had a snowpack problem. We know that it was messing up levels in lakes. Remember that Lake McClure, that the water wasn't even high enough for the intake valves to give it to the communities that needed it back in 2015. But we have to think about this. Wind is actually the vehicle that drives in precipitation events. So the lack of snowpack can be attributed to wind or wind patterns. And so that's what we're going to be working on in the coming days. What's going on in California in in 2015 that would have caused this issue with the wind patterns and then the issue with precipitation. So I miss getting to teach you in person. I would have loved to have seen some of you dressed up as the Sun King and the Pressure Fairy. Please don't hesitate to reach out if you have any questions. It seems to be working well to talk to some of you on the phone. It's just quicker and more efficient to get you to understand. All right, bye all.